Welcome to Linear Correlation and Regression, the car weight and fuel consumption example. Listed below are the weights in pounds of fuel consumption and highway fuel consumption in miles per gallon of randomly selected cars. The Chrysler Sebring, the Ford Mustang, BMW, Ford Crown, Honda Civic, Mazda Protege, and Hyundai Accent. The weight given for the following is, I'm going to read them off and you can type them into the technology you're using. The weight is 3175, 3450, 3225, 3985, 2440, 2500, 2290. The fuel consumption correspondingly is 27, 29, 27, 24, 37, 34, 37. So the first thing we're going to do is find the value of the linear correlation coefficient. I'm going to use StatCrunch, but you can use any other form of technology as well. So go ahead and bring up StatCrunch here. And I have these already typed in. I'm going to go to Stat, and then I'm going to choose Regression, and I'm going to choose Simple Linear. And before I do that, make sure to change the variable 1 column to X and the variable 2 column to Y. That makes it a lot easier for us. So now I'm going to choose the X variable as X, the Y variable as Y. And basically I just leave everything else the same. I'm going to hit compute at the bottom right. Now let's move this over here and look at our screen. So if we go ahead and look at the plot, we can go ahead and see that the X, remember, is the weight and the highway fuel consumption is the Y. So as the weight increases, we can see the fuel consumption decreases. So the slope of this line, or the line, tends to go downwards. And we can predict that there is a negative linear correlation because it's going down, but we can't assume there's enough evidence to support that. So let's go ahead and look at our R correlation coefficient. Our R correlation coefficient is right here. So it's negative 0.94. I'm going to write that down while I'm talking. Negative 0.94392691. I'm going to write it all out. Now we're going to have to do a correlation or a linear correlation hypothesis test. So for this, H sub O is going to be, we're going to assume rho equals 0. So we're going to assume no linear correlation exists. Okay, remember, because if R is 0, that means there's no linear correlation. H sub A is going to be rho does not equal to 0, so this is going to indicate some linear correlation exists. I like the words as well as the symbols here to help understand the values better. Now, remember, in the traditional method, we can use the critical value R by looking at the table. So there are 1, 2, 3, 4, 5, 6, 7 sets of data, so 7 vehicles. I'm going to go ahead and bring up my critical value chart here. So there's 7 set of vehicles, and let's remind ourselves of our alpha level is 0.05. So we go ahead and match those up. Go down to row 7 over to where alpha is 5, 0.754. So this is going to be, the critical values are plus or minus 0.754. I'm writing that down. Now, back to this. Remember, what we can do is we can look at that on the scale from -1 to +1, 0 being in the middle. Remember, 0 is no linear correlation. And our critical value R is negative 0.94. I'm sorry, that's not our critical value, our linear correlation coefficient. But our cutoff marks are the positive and the negative 0.754. So those are the critical values. Is negative 0.754, and going to be the other critical value is positive 0.754. So you can clearly see here that the negative 0.94 lies to the left of negative 0.754 0.054. So there's going to indicate that there is some negative linear correlation. So then we can also do the p-value method. So the p-value method, remember, we are going to get our test statistic and everything from StatCrunch. So let's go ahead and do that. We're going to look at our test statistic and where it says slope. Okay, so our test statistic on StatCrunch is negative 6.39300214. Our p-value is 0.0014. And remember, this is a two-tailed test because it's not equal to. So our p-value is going to be definitely less than our significance level. So 0.0014, let me change screens here. 0.0014 is definitely less than our significance level of 0.05. And so that makes our decision that we're going to reject the null hypothesis. Reject the null hypothesis. So our statement should say something like this. The sample data does, remember when it's rejected, does provide sufficient evidence to suggest A, and this is where we choose positive or negative, or we leave it blank. Well, remember, according to the graph, it was going down to the right, so that indicates negative. Also, our R correlation coefficient, since it's negative, we're going to say a negative linear correlation exists between a car's weight, and we're going to use the units in pounds, and the highway fuel consumption in miles per gallon. And we're going to say at alpha equals 0.05. So it says next. So we have some linear correlation there and it's negative. So we're going to find the regression equation. Remember, we're going to use y hat. We're going to go back to StatCrunch to read that. So on StatCrunch, we're going to look for the y equals, since we had changed the column headers, it makes it easy. So we're going to go y hat equals 54.695038 minus 0.007968918 Remember, the component with the x is the slope, so that's negative, and the y-intercept is the 54. Sometimes you might see it written the other way around. On D, it says, find the best highway fuel consumption for a car that weighs 3,000 pounds. So what we're going to have to do is substitute 3,000 into that equation. So let's go ahead and write that out. We're going to write y hat equals 54. I'm going to rewrite everything from the first equation. Except instead of x, I'm going to put the 3,000 pounds. Equals, and then I get my calculator. So on our calculator, we're going to put that all in, 54.695038 minus 0.007968918 times x, which is 3,000, and we hit enter. And so we're going to get 30.78882831. And our units, remember, we're predicting the fuel consumption, so this would be in miles per gallon. And so the next one would be 5,000 pounds. The thing is with this one, for E, we have to look for a fact that if it weighs 5,000 pounds, if you look at the car weights from the initial set of data, the initial set of weight, which was our x here, it goes from 3,000, and most of them are in the 3,000, somewhere in the 2,000s, but 5,000 is called an outlier, okay? So So this is an outlier. So since it's an outlier, we're not able to predict. It might say that it's not meaningful. And the last part says, repeat example 2 by switching car's weight and fuel consumption and notice any changes. So what we're going to do is we're just going to go ahead and look at this quickly in StatCrunch. So let me pull that up again. And all I'm going to do is I'm not going to just type in the X and Y columns. I'm going to go under Options and Edit. I'm going to switch the X and Y columns here. So in the X variable, I'm going to choose Y, and in the Y variable, I'm going to choose X and hit Compute. And let's notice maybe some of the differences here. So the R correlation coefficient, if you notice here, it's still negative 0.94. So the correlation coefficient stays the same. Let's looking at the graph. The graph still goes down to the right, but notice here the Y now is the horizontal axis, and the X, the weight, is the Y axis. Going back here, our equation now is going to be the X equals, and notice it has changed. It's 6,443.424 minus 111.80915Y. So the equation does change there. If we look at our test statistic and our p-value, our test statistic and our p-value stay the same. So basically the equation is the only difference that's going to happen if you interchange the X and Y values.